My name is Mike Celia. I'm the director of the Princeton Environmental Institute. And on behalf of all my colleagues, I want to welcome all of you to this first Taplin Environmental Lecture series, lecture for this semester. This Taplin lecture series is named after Frank Taplin, class of 1937 from Princeton. Frank was a terrific supporter of many environmental causes and a great supporter of Princeton University, and when you put the two together, that meant he was also a terrific supporter of the Princeton Environmental Institute, PEI, including providing funds for these kinds of lectures that are meant for public lectures. And it really is our great pleasure to have as our first speaker of the semester Peter Gleick. Anyone who's worked in water will know his name. Peter has an engineering degree from Yale, has a bachelor's degree. He then went to Berkeley for both master and PhD and liked it there so much that he never left. In fact, soon after finishing his PhD, he co-founded something called the Pacific Institute. And he has served as president of the Pacific Institute from its founding in 1987 until last year, 2016, and he is now President Emeritus, and since being Emeritus might imply that he's slowing down, he's also taken on the title of Chief Scientist, just to make it clear that he's in fact not slowing down as far as I can tell. It's difficult for me to disentangle Peter and the Institute, because for me the two sort of go hand in hand all the time. The focus of the Institute is broadly on water issues as they intersect and interact with almost all disciplines that you can think of. Peter's own work, at least for part of the time, has focused on the intersection between water and climate change. And he's done seminal work in these topics, even though someone seems to be hitting a home run right now. Anyway, Simon, you can clue us in after the smartphones always do it all by themselves. Anyway, back to the topic at hand. Peter has pioneered many different things, two of which I'll mention. The idea of peak water, which he developed by analogy to the earlier concept of peak oil, if you pay attention to that. And interestingly, what he calls a soft path for water, which is a kind of sustainable transition into a long-term sustainable use of water. The Institute, the Pacific Institute, if you've done anything related to water, you will know that they produce what they call a biennial report on freshwater resources. It goes by the title, The World's Water. And I've certainly used it in a number of courses that I have taught, and probably many in the audience have done the same. It's a remarkable resource, one of many things that get produced from the Pacific Institute. Peter's very widely published. He has many awards. I'll only mention two to end this, what's supposed to be a brief introduction. In 2003, he received the MacArthur Foundation Fellowship, which is typically known as the Genius Award. And in 2006, he was elected to the National Academy of Sciences. So please join me in welcoming today's speaker, Peter.
Well, good afternoon, everybody. Thank you for coming. I do a lot of public speaking. I like to speak in public. I've given, I don't know how many public lectures, but I have to say I'm a little discombobulated at the moment, because I have to tell you a little story. The very first public lecture I ever gave on my work was before I had my, at Princeton, was before I got my doctorate. I was doing research at the University of California on the integrating regional hydrologic models with output from general circulation models, GCMs. And I had developed this methodology, and I was doing the work, and I had most of my results, and I had come to Princeton to talk about the methods that I was using and my results, and I gave my lecture, and I finished my lecture, and at the end of the lecture, as typically we do, some people raised their hands to ask some questions. And Professor Sukiro Manabe, who I don't know if any of you know, but you all should know, raised his hand from the Geophysical Fluid Dynamics lab, and he said, "What about this?" And he asked me a question that took me 6 months to answer and forced me to redo my models and to redo my calculations, and it was an experience that a graduate student and now somebody who's emeritus will never forget. And so I'm waiting here to come in, and Suki is standing outside the door. Raise your hand. So for those of you who don't know who he is, he's one of the pioneers, really, of the entire field of general circulation models in the climate world. He and his colleagues, Dick Weatherald and many others, really created the first functional, and to this day, still remarkably accurate general circulation models of the climate that every general circulation model of the climate is based on. And it's a delight and a horrible thing to see. And if there are questions afterwards, I'm not calling it. Okay, thank you. So I'm going to talk about water. I'm going to talk a little bit about the crisis that we face in water resources, a little bit about the future of water, and in the context in particular of climate, the human right to water, and international conflicts over water, which are three pieces of this broad puzzle. And then I'm going to close with some thoughts about some of the solutions I see to our water challenges. So first, a little bit of a reminder of the importance of a modern water system, which the reality is most of us take completely for granted. Water is connected to everything we care about. It's connected to certainly the production of food. It's a fundamental part of our climate system. There's connections with water in the debates we're having nationwide and worldwide about infrastructure. It's connected to forest health. It's connected to ecosystem health. It's connected to human health, and so on. If you're interested in sort of anything in the natural sciences and human society, there's a connection to fresh water. And that's one of the things that makes it such an interesting topic. It's one of the things that the Pacific Institute has worked on for 30 years now, and there is no shortage of need for research and analysis and policy work and communications around fresh water issues. The World Economic Forum, every year that meets in Davos, produces a report on global risks. This is a graphic from that. I've drawn an arrow to water crises, which is one of the top risks that they identified. But it's a little hard to read, but above that is spread of infectious diseases and food crises and extreme weather events and biodiversity loss and failure of climate change mitigation and adaptation. All of those are water related as well. So there is a growing realization that there are deeply interconnected challenges associated with water. There are growing risks associated with water, and we had better do something about them. So a little bit of global context. I'm just going to sort of present the bad news first. There are billions of people worldwide that don't have access to safe drinking water and sanitation. The estimate is probably 700 million people worldwide still do not have safe drinking water. 2.5 billion or 2.4 billion, about 40% of the world's population that still does not have access to adequate sanitation. And the failure to meet basic human needs for water is the cause of many of our woes today. Water-related diseases, cholera, dysentery, guinea worm, schistosomiasis, a whole series of bad things happen because we have failed to meet basic human needs for safe water and sanitation. We have deteriorating natural ecosystems. All of the water that humans use comes out of natural ecosystems, and many of the challenges associated with threatened and endangered aquatic species and disappearing rivers and lakes and loss of wetlands can be tied to human extraction of water from these natural ecosystems. We have parts of the world that do not have basic water infrastructure, and we have parts of the world that do have infrastructure, but that infrastructure is aging, and we're failing to invest in maintaining that infrastructure, and I'll come back to that. We have little public awareness about water problems, although that's changing. There is more and more awareness of these water problems, and more attention is being paid to that. There is conflict, violent conflict over access to water or use of water as a weapon or attacks on water systems. There is a long history and unfortunately an increasing amount of conflict worldwide over fresh water resources. We have climate change. We have few coherent international water policies, and I would argue we have few coherent national water policies, and the national debate about water is going in the wrong direction. And so all of these problems raise the question, what do we do about these things? Now I could give a long talk about each of these. I'm really going to focus on pieces of this puzzle. I'm going to talk about basic human needs for water and the human right to water. I'm going to talk about climate change and connections with fresh water resources. I'm going to talk about international conflicts over water. And then I'm going to end with some thoughts about solutions. But I don't want you to think these other problems that I'm not going to address are unimportant for those of you who, for example, work on natural ecosystems. I'm not giving you really short thing. So let me start with climate and water. I suspect I don't need to say this to this particular audience, but the climate is changing. It's changing because of human activities. And those impacts are going to be, over time, they're already evident and they're going to be increasingly severe. The science is unambiguous about all three of those points. It's indisputable, not that it's not disputed, but it's indisputable. This is one tiny piece of this puzzle. This is a graph of 800,000 years of ice core data showing concentrations of CO2 in the atmosphere. We have similar data going back to about 1 million years based on paleoclimate records on temperature. And you can see a lot of different things in this graph. You can see periods of time going back 800,000 years to the present, just to orient you, 800,000 years ago to the present. We have periods of time when CO2 was high, we have periods when CO2 was low. This shows natural fluctuations in the climate. We know that climate changes naturally, and we understand the reasons why that have to do with orbital dynamics and the precession of the Earth and all sorts of large-scale geophysical characteristics that cause natural climate changes. And when CO2 is high in the atmosphere, we have interglacial periods, and the Earth is relatively warm. And when CO2 is low, we have glacial periods because of the dynamics and the physics of greenhouse gases in the atmosphere. And all of this is very well understood. And here we are today. The y-axis is parts per million of carbon dioxide in the atmosphere. Right now, we're about 405 parts per million in the atmosphere, higher than has been seen in this 800,000 year record, and frankly, probably higher than we've seen in 5 million years. And this is industrialization. This is the human influence on climate. This is the emissions of greenhouse gases from burning of fossil fuels and agricultural activities and the other things that emit greenhouse gases into the atmosphere. This is not natural climate change. And the hydrologic cycle is the climate cycle. The climate cycle is the hydrologic cycle. And you all remember the hydrologic cycle from second grade, I'm sure. That is evaporation, the formation of clouds, condensation and rain or snow onto land or the oceans, precipitation, runoff back to the oceans, the hydrologic cycle. This is, again, well understood, and this is the climate cycle. As we change the climate, we will affect every aspect of this, evaporation rates, formation of clouds, precipitation characteristics, the timing of runoff, the demand for water, all of this is connected. And so some people say if climate change is the shark, water resources are the teeth. That's what's going to bite us. There will, of course, will be many other implications of climate change on agriculture, human health, impacts on ecosystems, but many of those things can be tied back to water and water resources. And there are a lot of pieces to this puzzle, both impacts on the natural hydrologic cycle, but also on the built water systems that we have put in place to manage that natural hydrologic cycle. And this isn't a future threat. This is a current reality. The evidence is already clear that climate changes, human-caused climate changes, are already affecting the hydrologic cycle. And there are lots of examples. This is a map of the United States showing climate model projections from one particular set of climate models, and they all show similar trends for future precipitation in the United States. And there will be regions of the world where precipitation goes up, typically the northern latitudes because of the way we distribute water around the planet. In the United States, the estimates are that in particular we'll see decreases in precipitation in the southwest and the western United States. This is sort of the opposite of what we would want. If we could choose, we would sort of like wet areas to get drier and dry areas to get wetter. But that's not the way the hydrologic cycle distributes water around the planet. And the models suggest that wet areas will get wetter and dry areas will get drier on average. There's still lots of research to be done on the details of impacts on precipitation, but this already suggests a bad thing. When you look at changes in precipitation, but also changes in temperatures going up everywhere, effectively, which affects demand for water and evaporation and transpiration of water. And you put that together with both general circulation models, but also regional hydrologic models, and you look at projections of runoff, the news again is bad, and it suggests the Southwest is going to be particularly hard hit. This shows one projection of changes of runoff, and the redder or yellower or orange the color, the greater the decreases in runoff. And this shows again the southwestern United States is likely to experience greater decreases in runoff and greater decreases in runoff than many other parts of the United States. Okay, this has a mind of its own, which I'll have to pay attention to. There are also going to be changes, not in absolute amount of water availability, but in the timing. And some of the research that I did for my dissertation and since then was looking at the effects of climate change on snowfall and snowmelt. And one of the things we understand is that higher temperatures alone will drive changes, especially in snowmelt-driven basins, in the timing of runoff. Higher temperature means more rain, less snow. What does fall as snow runs off earlier, and that affects water availability in especially mountainous regions. And this is a projection of changes in the timing of peak runoff from western basins. And the redder the color and the bigger the circle, the earlier the timing of snowmelt. And this suggests that by the end of this century, we could see several weeks earlier runoff from some of these basins. And that's a water management challenge. It's got impacts on ecosystems that we don't fully understand but are going to have to deal with. Higher winter runoff means greater flooding in the winter. What this partly also means is that there will be less snow in the spring and summer. And a lot of these western basins rely on late spring runoff for water supply for those regions. All of this is a water management challenge. We're going to see more extreme weather events. This is a little picture from an event in 2011 that resulted in what was effectively a 1 in a 500-year flood event on the Mississippi. And that's this precipitation extreme. This is a measure of extreme precipitation percent increase in precipitation would have 600% higher than average precipitation, but it also shows simultaneously that Texas was in one of the most severe droughts in the historical record at the same time. So the idea that we're going to see more extremes of wet and dry periods is one of the challenges that we face. This is a satellite image of what we call an atmospheric river. The western United States gets a lot of its rain in these atmospheric rivers that come off the Pacific that deliver a lot of water in a fairly narrow band over a fairly short period of time. And one or two more atmospheric rivers every season, or one or two fewer atmospheric rivers in a season, is the difference for California between a wet year and a dry year. So how storms are changing in the Pacific is a very important factor in water availability in the western United States, for example. This is an image, satellite image of Superstorm Sandy, severe. Interestingly, we don't actually call it a hurricane because by the time it struck land, it had been downgraded from a hurricane to what we've now named a superstorm. Not that that had much of an effect on the seriousness of the impacts. And we are going to see more and more influence of climate change on these kinds of storm events. And this is a satellite image from about a week ago. After Harvey, before Maria, this shows hurricanes Irma, Jose, and Katia. Katia, Irma, and Jose, followed by Maria, which was out here, that basically followed almost exactly the same path as Irma. And these have been, as you know, anybody who's paying any attention to the news, absolutely devastating from a human perspective. And even today, the consequences are not adequately being dealt with. And the discussion about the science, about attributing storms to climate change, the influence of climate change on the strength or severity or paths of these storms is one of the most interesting aspects of climate science today. There's still a tremendous amount of work to be done. But we do know that higher sea level is a reality. And a storm surge with higher sea level is a more damaging storm surge than it otherwise would have been. Higher sea surface temperatures influences the amount of energy these storms get. Warmer temperatures influences the amount of vapor, water vapor, and the precipitation that these storms deliver. So these are all challenges and connections between climate change and water resources. I live in California. We've just come off of the worst 5-year drought in the historic record. This is a graph that shows from the year 2000 basically to late 2016 the percentage of the state that is considered to be in drought by a measure from the Drought Monitor. It's something in the University of Nebraska, the U.S. Drought Monitor. And you can see this 5-year drought when basically, effectively, 80, 90, or 100% of the state was considered to be some form of drought. That's this 5-year drought. Although interestingly, we've sort of had 10 years of drought with a year or two of a little bit of a reprieve in between. And this 5-year drought was, as I mentioned, the most severe on record by pretty much any measure. We had the lowest snowpack in a couple of these years ever recorded. And then that was followed this year by the wettest year on record. This is a graph. Our water year is from October 1st to September 30th. The water year is almost over. A couple more days, the California water year has ended. And this shows for Northern California, it's pretty hard to see the colors here, but this sort of light blue, this is an average amount of rainfall over this 125-year period. This is the driest year on record in inches per year. And this is last year, 190% of normal. It's the wettest year on record, following 5 of the driest years on record. I'm not arguing that this was caused by climate change, but we do know that climate change is influencing these extreme events. Interestingly enough, on a personal note, You mentioned that I'm now emeritus at the Institute. That means I get to spend no time on administrative stuff and all the time I want on research and writing. And I'm trying to do half of that from home. But in order to do that, I sort of had to build a little bit of a home office. And in order to do that, we're doing a little bit of a renovation. And on October 1st, last year, we took the roof off our house. And spent 5 months with tarps and leaks and watching. I have never paid more attention to the weather. And it's just, it's sort of bad karma. But each of these is a storm. And we barely had a couple of days in between storms. And the truth is they're still working on that. It's been a year. I don't take credit for solving the drought, but we're seeing more and more billion-dollar disasters, even correcting for inflation. Every state in the union, these are water and weather-related disasters, has experienced billion-dollar disasters over the last 30-plus years. And Munich Re, which is the world's largest reinsurance agency which pays attention to weather and climate-related risk, concluded some time ago, quote, the only plausible explanation for the rise in weather-related catastrophes, and this is a graph of weather-related catastrophes over time, from 1980 up until the present, is climate change. So they don't have the luxury of denying the reality of the science. This is their business. They pay attention to risk, they pay attention to changes in risk dynamics over time, and they pay attention to science. This is going to cause a big shakeup in the insurance industry. It's going to cause long-term changes in the way we do land use planning, things that we're not yet coming to grips with in any aspect of the climate risk world. And on top of this is the stuff that we've built. We've spent worldwide trillions, literally trillions of dollars, building water-related infrastructure to deliver water to us when we want it, to build dams for flood control, to prevent damaging floods, or to provide water supply in the event of droughts, to move water from one basin to another, water treatment plants, wastewater treatment plants, often built at sea level in order to collect wastewater and treat it and throw it away. None of that infrastructure was built for a changing climate. All of that infrastructure was built and designed, and this is the way I was taught, partly as an engineer and a hydrology student, on the assumption that climate was fixed and static. And we would take the historical record, and we would use that to generate some sense of high and low flows and the statistics of hydrology, and that's what we would use to design our dams and our water systems. We now know that climate's not any longer static. It's variable, that's always been known. But now that variability itself is changing. And the infrastructure is not designed for that, and water managers are not prepared to deal with that. Let me talk a little more about the human right to water. I described at the beginning the failure to meet basic human needs for water. If there's any single piece of the global water crisis that you have to pick as worst, or that I would have to pick as the worst, that's it. It's inexcusable. We know how to provide safe water and sanitation for everyone. It's not a question of technology, it's not a question of money, it's a question of commitment, it's a question of governance, there's a long history about that failure, which I won't go into, but it's a failure. And the failure to meet basic human needs for water has led to a conversation for many, many years, for decades really, about how to address that failure. From a technology point of view, and from a money point of view, and from an international aid perspective, from a lot of different perspectives. But one of those perspectives was how to think about access to water and whether there is a human right to water. Charles Darwin said, if the misery of our poor be caused not by the laws of nature, but by our institutions, great is our sin. And that's the water story. The failure the misery of our poor from a water access perspective isn't caused by bad hydrologic cycle and the fact that some places are wet and some places are dry and sometimes we have storms and not everybody gets all the water we want. It's not the hydrologic cycle, it's our institutions. And great is our sin. And so the water community has talked about this for a long time. And there are water conferences, like the climate conferences, there are conferences in every one of your professional fields all the time. Some of us spend too much time at them. But in 1977 really was one of the first international water conferences in Mar del Plata. And one of the conference statements of that was all peoples have the right to have access to drinking water in quantities and of a quality equal to their basic needs. And that phrase, to parse it a little bit, talks about drinking water. It talks about amount and quality of water, both of which are critical pieces. And it talks about basic needs. Not an infinite amount of water, but water for basic needs. In Dublin, there was a conference in '92 that said, quote, "It is vital to recognize first the basic right of all human beings to have access to clean water and sanitation at an affordable price." So there's been a little evolution in thinking. So again, they talk about a right, and they talk about sanitation for the first time, and they talk about economics, an affordable price. Affordability is a piece of this puzzle. And so during this period of time and subsequently, there were simultaneously conferences and discussions about, is there a legal human right to water at the UN? Now, I won't go into the long detail about that. That conversation went on for decades. But ultimately, in 2010, the Human Rights Council of Geneva passed a resolution that was then adopted and passed by the General Assembly of the United Nations, affirming that the human right to safe drinking water and sanitation is derived from, and there's a lot of verbiage here, but the right to an adequate standard of living, inextricably related to the right to the highest attainable standard of physical and mental health, and the right to life and human dignity. What they're basically saying is there are all of these other rights that have already been affirmed by the United Nations and the world community. Right to health, the right to a standard of living, right to the political and social and economic rights, for those of you interested in the human rights jargon. And that the human right to water and sanitation is a part of that. And it's a legal binding right. And that was a remarkable advance, political advance. Pope Francis in 2015 issued the encyclical letter, Laudato Si', which many of you may be familiar with from a climate perspective. A lot of it was focused on the issue of climate change and poverty. But from my perspective, I read it with my filter, and my filter is partly water. And there were all sorts of remarkable statements in there also about water, and this is one of them. Access to safe, drinkable water is a basic and universal human right, since it is essential to human survival and as such is a condition for the exercise of other human rights. And since then, there have been meetings at the Pontifical Academy of Sciences about the human right to water. This was a meeting in March 2017, and a statement was issued again by the Vatican Academy of Sciences, the Pontifical Academy of Sciences, about the human right to water and the responsibility of nation states and governments and individuals and organizations to work toward meeting that human right. A couple of comments about this. One is, access to water is not just a problem in developing countries. The second is a formal declaration of human rights to water, or rights to water and sanitation, doesn't guarantee that that'll be met. Maybe that's obvious, but we have human rights to a lot of things that we've failed to meet. And we continue to fail to meet the human right to water. And a strong economy doesn't by itself guarantee that the human right to water will be satisfied. And maybe this is the most obvious, immediate example. Here in the United States, in one of the large cities of the United States, we have a serious water crisis. We have a population that does not have access, even after 2+ years, more than 2 years of dealing with this problem, that does not have complete access to safe and affordable water. This is a failure of a lot of different things. It's a failure of infrastructure and investment in infrastructure. It's a failure of governance in monitoring and enforcing water quality. It's a failure of government in getting data about bad access to water and then failing to act on it. There are a lot of different failures involved here, but this is the United States, and we have populations that do not have access in 2017 to safe drinking water, and it's just inexcusable. And it's not just Flint. I do a lot of work on international water issues, but the Institute also works on Western U.S. water issues. There are populations in the Central Valley of California, typically disadvantaged communities, often farm worker communities, that don't have access to safe drinking water for a variety of reasons. One of them is the drought led to massive overdraft of groundwater pumping by agriculture that dried up some municipal wells, depriving small communities dependent on those wells of access to water. Another problem is there are communities that only have access to groundwater that's contaminated with nitrates. Nitrate contamination from agricultural fertilizers, from CAFOs, combined animal feeding operations, from bad septic systems, for lots of reasons. But we've known about that problem, the nitrate problem in the Central Valley of California, for decades. And we, the state of California, the federal government, have failed to provide solutions for that problem. And again, it's inexcusable. California, interestingly enough, passed a law about 1.5 years ago, 2 years ago, declaring a human right to water in California. But the language of that does not require that anybody in particular take actions to address these kinds of problems. It's sort of, I'll get in trouble for saying this, it's sort of a feel-good piece of legislation. It's a step in the right direction, but it's not a real active one, in my opinion. So the third piece of this that I just wanted to talk about in a little more detail is this issue of conflict over water. We do a lot of work at the Institute on water-related conflicts. We maintain something called the Water Conflict Chronology, which is the best database worldwide of violence related to water resources. This is a screenshot from one piece of this database. It's a map. Each one of these little bubbles is an example of violence over water. And the database goes back 4,500 years. The first recorded conflict over water, literally not chiseled in stone, but chiseled in a clay tablet, comes from ancient Mesopotamia, the region between the Tigris and the Euphrates River, when two city-states had a violent dispute over access to irrigation water from the Tigris and the Euphrates rivers. Ironically enough, some of the most recent entries in the database are from the Tigris and the Euphrates River, which is modern-day Turkey, Syria, and Iraq. And that database looks at all sorts of conflicts over water. It's conflicts related to access to water, as in, I want your water. It's attacks on water systems in conflicts that start for any other reason, but where water treatment systems or distribution systems or dams are attacked, which, by the way, is a violation of international law, not that it prevents it from happening. Or the use of water as a weapon. And there are examples where water itself has been used, either access to water has been used as a weapon, or water physically has been used as a weapon, again, in conflicts that may start for other reasons. So this isn't an issue of water wars, but it's an issue of violence related to some aspect of our challenges dealing with fresh water resources. And this is a graph that shows from 1930, this is from the database, the number of conflicts per year from 1930 up until last year, 2016, showing that we're seeing a big increase in the number of conflicts over water. Part of this may be a reporting question. Data, the farther back you go in time, is a little more difficult to obtain. But I think we're seeing a real increase in violent conflicts over water. And part of the work, ongoing work of the Institute is to try and analyze this, understand the nature of these conflicts, to look at trends in these conflicts, what kind of conflicts are we seeing, to look at the kinds of regions and parties where these conflicts are occurring, and then subsequently to look at ways of reducing the risks of conflicts. And it doesn't show in this graph, but an important characteristic of this is these are largely not nation-to-nation conflicts. These are subnational conflicts. These are conflicts in civil wars. These are conflicts between ethnic groups or ideological groups, between farmers and pastoralists in East Africa. Unfortunately, a lot of the increases from countries in the Middle East where there are ongoing conflicts for ideological and political and religious reasons, but where water has become entwined in those conflicts. So that's all I'm going to say about that. Let me talk about solutions a little bit, and maybe give you a little bit of the good news aspects of this. I've done quite a bit of work trying to think about integrated ways of dealing with water-related challenges. And one of the ways I've tried to frame this is I call the soft path for water. A lot of that work takes off on work from the world of energy that some of you may be more familiar with, and work that is done on a soft path for energy. And let me describe sort of quickly what I think about this. I'll describe the hard path and the soft path. And the hard path is sort of a generic way of talking about what we did in the 20th century to deal with water resources. And the soft path is a little bit of my vision for where I think we need to move in thinking about water in the 21st century. So the hard path built water infrastructure for water supply. It built dams and reservoirs and aqueducts and delivery systems to get water from where we had it in the natural environment to where we wanted it, in our agricultural fields, in our cities. And that was a great thing. All of us are we've completely benefited from that infrastructure investment. We live in cities that don't have enough water by themselves anywhere to provide for our demands, and we've gone far afield and we move water around, and we treat water to a very high standard. And that focus on water supply was a good thing, largely. But the soft path for water asks us to rethink what we mean by supply. And I'll come back to give you some examples in that. The hard path focused on assuming that there would be a certain kind of demand for water as a function of population growth, as a function of assumptions about where our economy was going and what kinds of industry we were building. And it said, all right, we will build supply to meet some assumed demand for water. And we do this, and we did this in the energy world as well. We would make projections about, in 50 years, the demand for energy is going to be this, and so we're going to have to build 100 nuclear power plants on the coast of California, which was something they planned to do. And we would build supply to meet some projection of demand. And the soft path says, wait, let's rethink what we really mean by demand. And I'll come back to that too. The hard path said water's an economic good. Let's treat it as an economic good, and that's the way we'll think about it. And the soft path says water is an economic good, and it's a human right. And how do we balance the human right to water and economic goods and services? It's a different way of thinking about water, and we're wrestling with that. Hard path focused on centralized systems, centralized treatment systems, distribution systems, delivering potable water. All of you have one set of pipes that come into your house and it delivers potable water. Even though You don't need potable water to flush your toilets or to water your lawns. That's the system we built for a lot of different reasons. And the soft path says protect water supply, which reduces treatment requirements, changes the way we think about water quality, but also let's match the different qualities of water that we have in different places with the quality of the water that we need. And that better matching might open up new opportunities for managing and treating and delivering water in a different way. The hard path gave no thought to natural ecosystems. We didn't care, or we didn't know we ought to care about the impacts of our water system on the natural environment. And the soft path says we can't do that any longer. We have to understand the connection with natural ecosystems. We have to understand the value that natural ecosystems provide to us. We have to integrate our decisions about water with natural ecosystem considerations as well. The hard path had centralized organizations and institutions and water agencies, and the soft path says rethink management inside of this. Integrate decisions that water utilities might make with decisions that energy utilities might make. It takes a lot of water to produce energy. It takes a lot of energy to treat, deliver, use water. But we always thought about energy over here and water over here. And now there's a whole field of study that's sort of been nicknamed the water-energy nexus that is thinking about those things. Similarly, agriculture, the assumption was we have to grow food to meet some projection of future population demand for food. We assume the water will be available or we'll deliver it. And that's caused all sorts of problems. So let's think about water and energy and food institutions together. It's a different management approach. And the soft path says, think more broadly about that. So back to this question about supply for a minute. When I say rethink supply for the soft path, here's an example. In the developed world where we have sophisticated centralized wastewater treatment plants, we collect wastewater, we treat it to a very high standard, typically in the United States and Europe and elsewhere, and then typically we throw it away. We dump it in the ocean, if you're on the coast. And now we're beginning to think, you know what, that wastewater is a source of supply. We can use highly treated wastewater, depending on the level we choose to treat it to, and we can treat it to perfectly potable standards. We can use it for all sorts of things. And in regions where there is no more new water to be found, all of a sudden, this is a source of supply. In California, we now reuse about 15% of our wastewater. Israel reuses 75 or 80% of its wastewater for ecosystem flows, for agricultural uses, for industrial heating and cooling purposes, for lots of different things, up to and including, potentially, potable use. In Namibia, Windhoek, Namibia, the capital of Namibia, they've had a direct potable reuse wastewater system for 30 years. In Singapore, they have a very sophisticated wastewater system that they call New Water. They've branded it New Water, and it's part of their water supply system, and we're going to see more and more of that. Desalination is a potential source of new supply, and we know how to desalinate. Salt water is 97% of the water on the planet. Only 3% is fresh water. And most of that fresh water isn't accessible to us anyway. And so everybody says, well, what about desalination? Okay, we know how to desalinate. We've been desalinating water in one form or another for a century or more. It's very expensive. Economically, it's expensive. The energy cost is high. It's capital intensive because of the technology. But in places where other things are now not available, when there's no new source of water, when we've done the things we need to do on water conservation and efficiency, which I'll come to in a second, this is an option. Israel has restructured its agriculture. They're using 75 or 80% of their wastewater, and now they're building desalination plants. Desalination is a major source of supply for many of the countries of the Persian and Arabian Gulf, and have been for a long time. So it's a potential new source of water that doesn't require tapping a river, drilling a groundwater well, taking more water out of natural ecosystems. More and more cities and rural areas are looking at how to capture more stormwater. We get a lot of our water in many places of the world in very short periods of time, in intense storms, and potentially in some places more intense storms. And we're thinking about capturing more of that water. In the old days, a hard path, our stormwater systems were, how can we channel that water and get it away from us as quickly as possible? Typically to the ocean. But now, smart urban design is thinking about how to capture more of this for groundwater recharge, for restoring urban streams, for improving the quality of life in urban centers. And that's an increasing challenge, stormwater capture. Those are all new ways of thinking about supply that are not traditional, that don't require building another dam. On the demand side, I talk about rethinking demand, and here's what I mean about that. We don't, except for really basic human needs, we don't want to use water. We want goods and services. We want to grow food. We want to do things in our home with water. We want clean clothes. We want to wash our dishes. We want to make goods and services in our factories. If we can do those things that we want, if we can provide the goods and services that we want with less water, that's the concept of demand management. And it's true in energy and it's true in water. If we can improve the efficiency of water use, we can do what we want with less pressure on our existing systems. 80% of the water used by humans worldwide goes to agriculture. 20% goes to residential, commercial, industrial, institutional uses. If we can grow more food with less water, that's a huge, huge advantage. It's a huge positive potential impact on rivers and streams and groundwater systems. And there is almost no better way to evaporate water to the atmosphere unproductively than some of the irrigation technologies that we developed under the hard path. These sprinkler systems that spray water into the air, it's just a great way to lose water to evaporation, and as temperatures go up, to lose more water to evaporation. But conversely, there are new technologies for measuring soil moisture, for precision delivery of water to crops, for better timing of water for farmers to know when their crops actually need irrigation water, that are improving our ability to grow food with much less water. Colloquially, we call it more crop per drop, and there's enormous potential to do that. And it's an important piece of the food puzzle as well. And the same is true in urban water use. The federal standard today for toilets in the United States is 1.6 gallons per flush. You can't buy a toilet legally that uses more than 1.6 gallons per flush. In California, the state standard is 1.3 gallons, 1.2 gallons per flush now. 30 years ago, the average toilet used 6 gallons per flush. And the truth is, smartly designed toilets, they work better than those old toilets because now we're thinking about it. That by itself is a 75 or 80% reduction in the water demand to flush a toilet. And most of you don't know it, but it's a huge improvement in reduction in providing a service. Front-loading washing machines use a fraction of the water and energy and detergent than the old top-loading washing machines. Smart outdoor landscaping uses much less water than traditional lawns. And why are we watering lawns anyway, especially with potable water? That's a big debate in the western US, but maybe not so much here. But there's a lot that we can do on the urban side as well. It used to take 200 tons of water to make a ton of steel in the United States in the 1920s. Today, the smartest steel plants in the world use 3 or 4 tons of water to make a ton of steel. That's a 98% reduction in water demand to make steel. There's an enormous potential for residential, commercial, industrial improvements in water use efficiency as well. There are new things going on in ecosystem restoration. This used to be the Elwha Dam on the Elwha River in Washington State. And about 1.5 years or 2 years ago, it was torn down. And within a really short period of time, the Elwha River started to restore itself. And now, salmon are 20 miles upstream from where the dam were. And they're spawning, and the delivery of sediment to the mouth of the Elwha has restored fisheries habitat in the ocean freshwater interface at the mouth of the Elwha. We're seeing more and more examples of trying to restore ecosystems as part of our water management. And that's a great good news story as well. So let me conclude by going back a little bit with some recommendations for these 3 pieces of the puzzle. The soft path for water is sort of an integrated way to think about this, but from a climate and a human rights and a conflict perspective, let me offer some thoughts. On climate change, we have to do 3 things, or we're going to do 3 things. We're going to mitigate, that is, reduce emissions of greenhouse gases and reduce the severity of climate change. We're going to adapt to those impacts that we can no longer avoid because we failed a long time ago to mitigate enough, or we're going to suffer. And frankly, the only choices, as John Holdren puts it, is the ratio of these 3 things. The less mitigation we do, the more adaptation and suffering we do, we're going to end up doing. The more mitigation we do, the less adaptation we're going to have to do, and the less suffering we're going to. It's a question of balance, and I don't know where we're going to end up on that equation. But we're faced with unavoidable impacts now that we're going to have to deal with. And we should think a little more carefully about dealing with those impacts that we just don't want to have to adapt to at all. That's a balance. And these are policy debates and long overdue. On the human right to water, we need to work toward meeting something called, pardon the acronym, the SDG, the Sustainable Development Goals of the United Nations. And just quickly, the United Nations has set a broad set of what are called Sustainable Development Goals, addressing poverty and environmental degradation and education, a whole series of things, targeted for 2030. SDG 6, the set of goals under SDG 6, are water related. One of those is 100% coverage of water and sanitation by the year 2030. That's the goal. And from a human rights perspective, that's a pretty great priority. And we have to figure out how to move forward between now and 2030 to satisfy 100% coverage for water, sanitation, hygiene, WASH, that's the acronym there. That's one key piece of this puzzle. Another is that we can declare a human right to water by the UN, but ultimately it's the responsibility of nations and states to meet their responsibilities under those human rights goals. And that means nations have to adopt a human right to water, and they have to move progressively to meet what that means. And frankly, SDG 6 is a key piece of that. But just declaring a human right to water isn't enough. We now have to act. A third piece of this is we have to invest in, or reinvest in, the things that provide what we want: safe water, sanitation, adequate ecosystems, all of the related pieces of the water management challenge. And we're not investing. We're grossly underinvesting in all aspects of that infrastructure. And on the water conflict side, meeting basic needs for water for everyone would reduce a lot of the pressures, a lot of the internal conflicts over access to safe water. A lot of those violent conflict examples from the database are I don't have water, and it leads to violence. And meeting basic needs for everyone will reduce the risk of conflict over water. Another is we need to improve and enforce international treaties. I mentioned that very few of those conflicts are nation to nation, but there are growing tensions on many watersheds that are shared by nations about access to water. Think about the Nile, a river in Egypt. But the truth is there are 10 nations that share the watershed of the Nile, and 9 of them are upstream of Egypt. And Egypt is 100% dependent on the flow of the Nile, and they care a lot politically about what happens upstream of them. And there are tensions. There's no treaty over the Nile. There's a 1959 treaty signed by Egypt and the Sudan, but the other 8 countries are not parties to it. We need better treaties on those shared international rivers. There's no treaty at all on the Tigris and the Euphrates. There's a 1960s treaty on the Indus between India and Pakistan that has worked for a while, but is beginning to fray politically. We have a treaty with Mexico on the Colorado River, and treaty with Canada on management of the Great Lakes. Those treaties are really important things. They're enormously effective at reducing the risk of conflict over water, but there aren't enough of them. And then we have to deal with the subnational piece of this. There are far fewer diplomatic and non-diplomatic tools for dealing with subnational conflicts over water, and we have to address that piece of the puzzle. So in conclusion, Nelson Mandela said this, interestingly enough, about water. He said, "It is one thing to find fault with an existing system. It is another thing altogether, a more difficult task, to replace it with another approach that is better." That's the world we're in. We grew up in a hard path world, and we have to replace it with a soft path world. And the good news is we're in that transition now. We sort of know what we need to do, and we see around us, if you look deeply enough, success stories in every aspect of this. And the trick is to make that transition happen even faster. Thank you very much.
Thank you, Peter. One quick announcement, which is for those who have time, we're going to have some questions now, and then you're all invited to go one floor up for a reception where we can carry on and continue the conversation. But for now, the floor is open for questions. Yes? You can just call.
Suki? Suki, got a question?
We have one over there.
Do you think that the LEED certification is emphasis on water as opposed to carbon footprint?
So the question is, does the LEED certification system put enough emphasis on water as opposed to energy and carbon? No. The LEED requirements for buildings are very weak for water. They weren't really designed with that in mind, but there are a couple, 2 or 3 water-related pieces of that. But we could redesign our buildings to use much less water, much more effectively. Now, there are other pieces to this. I mentioned the federal standards for toilets. There are federal standards for washing machines, dishwashers, for some water-related fixtures that by themselves mean buildings today use a lot less water than they used to. I mean, the per capita water use in the United States is going down. But we can do a lot more with standards, with enforcement of standards, with certifications around all sorts of water-using technologies.
The paradigm shifts that you've been discussing seem to emphasize a lot of the role of thinking in terms of systems and finding synergies across disciplines. What recommendations would you give universities, professors, administrators in terms of teaching skill sets to students across fields potentially that could help us have the tools that we need in order to carry out this paradigm shift that you're talking about?
So, when I started the Institute in 1987, hard for me to believe, but it was 30 years ago, one of the reasons was, I could have gone into traditional academia, but universities are not great. Princeton's a bit of an exception, and even 30 years ago was an exception, at interdisciplinary cross-departmental research and policy work. And that was what I was interested in doing. And so that's sort of how I would answer this. Universities, because water is connected to all these different things, it's not just hydrology and climatology, it's economics and political science and international security dynamics, and all of those things. It would be great if universities put time and effort and money into cross-disciplinary, interdisciplinary science and policy work. And there are a lot of different ways of doing it. Institutes, universities set up institutes. PEI is an example of a cross-disciplinary institute, and there are more and more of them. So the good news is that we're beginning to see some of those resources available. But we also have to train water professionals in a different way. This isn't just an engineering issue. I love to deal with water managers who understand economics and water law and climatology and so on. So that's an important piece of this.
You mentioned earlier that water is, among other things, an economic resource. To what extent do you feel that some of the challenges you described are a function of systemic mispricing of that resource?
Yes.
And globally?
That's an enormous piece of the puzzle. Water is badly priced. I said this in one of the talks I gave yesterday, so you've heard me say it again, I apologize. We pay less for water than almost any other of the things we care about. Our cell phones, our internet connection monthly, our cable TV bill, our energy bill. And the price we do pay for water, when we pay for water at all, doesn't reflect the true cost of the ecological damage that capturing and treating and moving water to us entails. So water pricing is a really important part of this. Farmers in the Central Valley of California don't pay enough for water. And for groundwater, they pay nothing except the cost of pumping. And if they were to pay more for water, and those that do pay for more for water, are more likely to be growing higher value crops and using efficient irrigation technology. That's a very important piece of the puzzle. It's related to the human right to water. If you read actually the UN Declaration on the Human Right to Water, they don't say water should be free. They do say that you cannot deny access to water for reasons of inability to pay. That would be a violation of human rights to water. And then we figure out how to subsidize poorest populations that can't pay for water. In the United States, there's a rough standard. It's an environmental justice standard adopted by the EPA that says if you pay more than a certain percentage of your monthly income, then you shouldn't have to pay more than a certain percentage of your monthly income for water. And if you do, it's an environmental justice problem, and the number is 2.5%. And there are many, many families in the United States that pay more than 2.5% of their monthly income on their water bill. And we have to figure out how to address that problem.
President, quick question. You mentioned the Oakland Dam piece. I think that's really fascinating. Out of Washington. When I graduated this year, I'd like to go work for the Army Corps for years. And so I have this attention of how do we address our dam infrastructure, especially in the 21st century with climate change. And I just really want you to get your perspective, because obviously there are huge benefits on the removal of dams. There's those that clamoring for removing all dams. But obviously, if you look at the dams, especially in Washington State and whatnot, there's a lot of priorities that they're fulfilling, especially when you talk about climate change, renewable energy. I'm just curious how you see the balance.
So we have tens of thousands of dams in the United States, and there are hundreds of thousands of dams worldwide. And I'm not arguing we need to remove them all. A lot of those dams are incredibly important to us. But there is a trend toward ecosystem restoration, and part of that trend is identifying really ecologically damaging dams that have little economic value and figuring out how to remove them. And this is a challenge for the U.S. Army Corps of Engineers and the Bureau of Reclamation and other dam building organizations whose mission for a century under the hard path was build another dam because of the benefits that they thought that they provide and that often they do provide. Those institutions are wrestling with this. What you're wrestling with, they're wrestling with, which is how do you manage the existing infrastructure? How do you build new infrastructure in an appropriate way? How do you remove bad infrastructure? It's the new challenge. The soft path doesn't mean don't build hard infrastructure. It means think about the infrastructure in a different way. And sometimes it means removing a dam, sometimes it means operating a dam differently. Different rule curves, different delivery systems so that you're protecting ecosystems as well as meeting human demands. That's going to be an exciting area. And frankly, the more people who can go to the Army Corps or the Bureau of Reclamation and get them to change the way they think, the better.
In your list, you allow for building new dams or only operating differently?
No, there are places we need new dams. They need to be built to a different standard. We have to think about ecosystems. We have to think about communities and the impacts on communities. We have to build them for a variable climate, a changing climate, not just a static climate. But the soft path doesn't mean don't build hard infrastructure. Yeah.
Peter, thank you for a very engaging talk. I was interested in your comments about the need for more treaties, while at the same time pointing out the problems with the Indus River Treaty and the Nile River Treaty.
Right.
And I wondered if you had any thoughts about how to incentivize upper riparians to agree to participate in river treaties.
Okay, there is a UN treaty, which I didn't talk about, called the International Water Courses Convention. It took decades to negotiate. And it lays out fundamental principles for sharing international water courses. Upstream riparians can't harm downstream riparians. Water should be shared equitably. I mean, they're very nice sounding principles, but implementing them is the challenge. And we have a lot of different situations. We have upstream nations that use a lot of water and don't really care what happens to downstream nations. And Turkey is upstream on the Tigris and the Euphrates, and Syria and Iraq are downstream. And Turkey is the geopolitical power among those nations. Egypt is a downstream nation on the Nile, and sort of is vulnerable to upstream decisions and is sensitive as a downstream. All of those, you can think about any situation and that prevails. It's hard to get upstream nations, especially politically or militarily powerful ones, to care much about what happens downstream. In the absence of some sort of negotiated treaty or some other political crisis. I don't know how to get a treaty on the Tigris and Euphrates, for example. I don't know how to get China to participate in an equitable fashion on the Mekong negotiations. The Mekong is shared by China and Laos and Cambodia and Vietnam and part of Thailand and a couple of other nations as well. And there's a Mekong River Commission, but China has not really been an active participant, and they're building dams very aggressively in the upper watershed. I don't have a great answer for that.
Let's take one more question. I know there's lots of questions around,
So back on the economics question.
Yeah.
Given the status of many public institutions in this country and proposed deep cuts in federal funding for states and localities to improve and even basically maintain water systems, I'm curious your thoughts on the whole issue. It's a great way to end the discussion with the privatization of water systems. Just a simple question.
Okay, so all of these have been great questions. Each one of them deserves its own hour and a half. There is a massive debate, and the Institute's written a lot about this issue, about this question of privatization. And privatization means a lot of different things, from private water utilities and operators to private ownership of water rights to the bottled water industry, and I wrote a separate book about bottled water, turning public water into a private commodity. I have a lot of opinions about privatization. I don't know which particular aspect you really are asking about, but boy, okay, I don't even know where to start on this, except to say, worldwide, we have public water systems and we have private water systems. We have well-run public water systems and we have well-run private water systems. And we have badly run public water systems and badly run. What determines the sustainability of the system, or whether it's well-run or whether it's meeting ecosystem demands, is typically not whether it's public or private. It's whether it's well-run. Private water systems, like public water systems, are monopolies, and so even where it's private, often there's a public agency that in theory is providing some sort of oversight. So in 1989, Great Britain privatized, Margaret Thatcher privatized all of the water systems in England. They were all public agencies, now they're all private agencies. And it was a disaster for a period of time, because there was no good public oversight. And that led to the Office of Water, the public Office of Water in England, imposing new rules and regulations on these private companies. And now they're much more effective. They're better run. So it's a big debate. The World Bank got into big fights in Cochabamba, Bolivia, and elsewhere about public versus private. People have strong feelings about it. It's an ongoing discussion about how best to move to a more sophisticated, smart, sustainable water system.
One very quick question, one very quick answer.
You talked about irrigation in agriculture. My question is, can you address the water problem without thinking about diet, more specifically meat consumption?
No.
It's a short question and
Well, it deserves a long answer, but the food issue, like the water issue or the energy issue, is very complicated. It's connected to all these other things that we care about. Anybody who says the answer to providing enough food for the world is expanding agricultural land or irrigating more or any single thing is missing a lot of pieces to the problem. We will address the food issue by improving irrigated agriculture and by improving yield on rain-fed agriculture and dealing with the food waste problem. A lot of the food that we grow never ends up as calories that people ingest. And diet. The amount of meat that we eat has a huge water footprint, which I think is really what you're getting at. And then one of the numbers I like to talk about is it takes 1,000 tons of water approximately to grow a ton of grain, wheat or rice, or there's variations depending on the climate, but it's about 1,000 tons of water to produce a ton of grain. And it takes about 15,000 tons of water to produce a ton of cow. Because the truth is, you're feeding a lot of grain to cow, and you throw a lot of cow away. And meat is a big piece of this puzzle. Meat-intensive diets are more water-intensive than vegetarian-intensive diets. Unfortunately, the dietary averages worldwide are moving toward meat. We eat a lot of meat. The developing world is beginning to eat more meat. And that's putting pressure on the water system.
please join me. Thank you. You're all welcome to join us one floor up. Brand new